We use it every single day, every second really. But how many of us actually know what the internet is? Well, in this explainer, we're going to trace the whole story, from a wild idea to the planet-spanning network that connects basically all of us. Okay, let's get into it.
Right? It's in our phones, our cars, our homes. It runs our entire lives. But if you had to explain it, what would you say? What is this thing, really?
All right, let's start at the very beginning with a solid foundational definition.
So, at its heart, the internet is really a network of networks. It's not one big thing. It's millions of separate computer networks all connected together. And the magic that lets them all speak to each other is a shared language called TCP/IP. You can think of TCP as the part that chops your data into little pieces and makes sure they all get put back together in the right order. And IP, that's the part that slaps an address on each of those pieces so it knows exactly where to go. It's basically the universal translator for the entire digital world.
But see, to even build this network of networks, the engineers had to totally throw out the old way of thinking about how information gets sent. It was a huge revolutionary leap.
So, on the left, you've got the old way, circuit switching. Think of an old-school telephone call. The network opened up one single dedicated line just for you and your conversation. It was rigid, kind of inefficient, but it worked. But on the right, that's the genius idea behind the internet. Packet switching. Instead of one dedicated line, your data, say an email, gets chopped up into tiny little packets. You can think of them like digital postcards. Each one gets an address, and they all find their own way through the network. Some might go this way, some might go that way, and then they get reassembled at the destination. The key word here is flexible. If one road is blocked, the postcards just find another route. This one simple idea, well, it changed everything.
So, how did this brilliant concept of packet switching actually become, a real thing? Well, that journey started with a few absolutely critical steps.
So the theory pops up in the 60s. By 1969, the US government put money into ARPANET, the very first real network to use this packet switching idea. Just a couple years later in '72, it got its first killer app, email. And then the final, crucial piece of the puzzle snapped into place in 1983 when TCP/IP officially became the standard. This created that universal language which finally allowed all these different separate networks to connect and form a true internet. Now, for a long time, the internet was this pretty niche thing for academics, scientists, and the military. But then the 1990s came along and something happened that blew the doors wide open and brought it to the rest of us.
That something was the World Wide Web. And this is a key point. The web isn't the internet. It's a user-friendly system that runs on top of the internet. With websites and hyperlinks and graphics, it suddenly made the internet something anyone could use. It was the revolution that put the internet into our homes.
And the web was so much more than just a collection of pages. It became a platform. It's the foundation that allowed things like Google to exist, that made e-commerce giants like Amazon possible, that gave rise to social networks like Facebook. The demand for all this cool stuff is what pushed us from dial-up to the high-speed fiber and 4G we have today. Pretty much everything we think of as the internet, yeah, it was built on the web.
Okay, so we often talk about the cloud or cyberspace, and it all sounds so floaty and magical. But the truth is, the internet is a very physical thing. And honestly, the reality is way more amazing.
The internet has a body. It's a real, tangible network of routers and switches and, get this, thousands and thousands of miles of massive fiber optic cables laid on the bottom of the ocean to physically connect the continents. So when you send a message from, say, New York to Tokyo, it is literally traveling as pulses of light through a cable at the bottom of the Pacific. How cool is that?
So how do you plug into this giant global machine? It's all done through this hierarchy. Way up at the top are the Tier 1 networks. These are the huge companies that own the massive international backbones, those undersea cables. They connect whole continents. Below them are Tier 2 networks, which are big regional providers. And finally, at the bottom, there's Tier 3. That's your local internet service provider, the company you pay every month. They buy access from the bigger guys and sell it to you. Your home connection is just the very last link in this enormous interconnected chain.
So, we've got the idea, we have the technology, and we have the physical infrastructure. So let's take a look at what actually happened when this thing went truly global.
This chart from 2018 really tells a story. You can see the developed world, in green, got an early start and was pretty saturated.
But look at that blue line for the developing world. You can see that steady, accelerating climb. That's where the real explosion of growth was happening, and it's what was pulling the whole global average up with it.
And what did all that growth lead to? It led to this number. By 2018, there were 4.3 billion internet users around the world. I mean, just think about that. That was more than half the entire population of the planet at the time.
And what's even more amazing is where that growth was centered. By 2018, Asia alone accounted for 51%. Yep, more than half of all internet users on Earth. That just goes to show you how much the internet's center of gravity had shifted across the globe.
So there you have it. We went from a really clever idea for sending data in postcards to a global system of undersea cables connecting more than half of humanity. It is an absolutely incredible story of innovation. And it really only leaves one question. After you've connected the world, what comes next?